This is Russ Woodruff at the University of Primorska, and today I want to show you Gap.app, the Macintosh interface to the Gap computer algebra system. I'm going to assume that you've already downloaded the Gap.app disk image file. As you can see, I have it right here on my desktop. Double-click to open the disk image. You install by simply dragging Gap.app to the Applications folder. That's it. If your edition of Gap.app includes Gap, as this one does not, then you'll have installed a complete working copy of Gap with just this simple step. Once you're done installing, you can eject the disk image and start Gap.app. The first time you start, you need to tell your Mac that you trust the Gap.app program. To do this, you can right-click or control-click on the Gap.app icon and choose Open. Your Mac will ask you if you're sure you want to open the application you downloaded from the internet. Click the Open button. You'll only need to take this extra step the first time you run Gap.app. Now you have a usual Gap session and you can type your usual Gap commands. For example, I'll set G to be the projective special linear group with dimension 2 over the field with 7 elements. Your normal Macintosh editing keys work exactly as you'd expect. Left arrow, right arrow, shift to select. Also working as command completion. For example, if you want the maximal subgroups of G, but don't remember the exact name of the command, or don't want to type the whole command, you can start typing part of it and hit Tab. If there are more than one completion for what you've typed, Gap will pop up a nice drop-down menu with all of the available completions. For example, when I typed maxim and hit Tab, it gives me a long list of things, and I can scroll down with mouse or keyboard to maximal subgroups and finish typing the command, and Gap will give me a list of all the maximal subgroups of my group, G equals PSL27. Also available are XGAP commands, including those to work interactively with subgroup lattices. The subgroup lattice command is graphic subgroup lattice. For example, if I type subgroup lattice of G in my current environment, it will display what looks initially like a rather sparse diagram. So I go to the subgroups menu on the sheet, and that has a number of options for adding subgroups to the diagram. Now, one thing I could do is ask for all subgroups, but since PSL27 is a fairly large group with a large number of subgroups, I don't want to do that right now. What I'll do instead is ask for a CLO2 subgroup of PSL27, and then I'll select that and take all the intermediate subgroups between the CLO2 subgroup and the full group, and then select those, and then take all the conjugates of these subgroups. And with just these few simple steps, I've gotten myself a diagram which shows me all of the 2' index subgroups of PSL27. As you can see, you can interactively rearrange the subgroups here. You also can interact by right-clicking or control-clicking on a particular subgroup. This will give you a pop-up with all sorts of information about properties of the subgroup size and index. If I click all to compute all the properties, it will give me isomorphism type and other summaries of resulting from that. If you're using Gap for significant computation, you'll likely want to keep an eye on memory usage. Gap.app makes this easy with the memory usage info inspector. You find this under the window menu. When I select memory usage info, it gives me an inspector which shows me the memory in use and the memory allocated by Gap. Both of these are out of the maximum memory that Gap will take, which is set in the application preferences. This inspector also gives me some detailed technical information about the Gap memory management system, or the so-called GasMan system. This is updated in real time. After working with Gap, you may want to go away and come back. Perhaps you need to restart your computer to install a security update. Gap.app makes saving and restoring sessions easy. Simply go to File, Save Session. It opens a Save panel, and I type in a file name, mycomputations.gapsession. .gapsession is, as you can see, the standard file extension for a saved Gap session. It saves it immediately and it compresses it in the background. Once it's saved, you can quit Gap.app, restart your computer, come back tomorrow, or come back right away. To restore, you can either double-click from the Finder or go to File, Open Session, and find mycomputations.gapsession and open it up. As you can see, Gap.app restores all your graphical windows. It also restores your complete command window, including all the commands that you've typed and all of the output that Gap has given you. Of course, your variables are still intact. If I ask what G is, it will return PSL27 again. In conclusion, Gap.app makes the power of the Gap computer algebra system accessible and easy to use for Macintosh users having varied levels of experience.